I want to talk about two problems with standardization. Standardization has been a very powerful tool, and it will become even more powerful as we continue on. In fact, the reason I have taught standardization is because it will eventually fall into G methods, into very standardized general methods, in order to approach causal inference problems in not only panel data, the stuff that we've been dealing with this so far, but longitudinal data, so data that varies over time, which is different from something like outcome regression, where lots and lots of problems happen. So standardization has been able to deal with exchangeability situations, conditional exchangeability situations, even censorship. So what's the problem with standardization? Why do we need to make any changes to it? It seems pretty good. Okay, I want to go ahead and list two situations. I want to go ahead and list a situation where we have L, which is our measured conditioned upon confounders. And I have, let's say, maybe 10 binary confounders. 10 binary confounders. So I got 10 binary confounders. And so these could be has a dog, does not have a dog, left-handed, not left-handed, has some coronary infraction, not some coronary infraction. They could be a lot of things. In fact, generally speaking, you'll have hundreds of binary confounders in more legitimate data sets. Okay? So you have 10 binary confounders, and let's say that you have a sample of, I don't know, maybe let's go with a high number, 300 individuals. 300 individuals. So you have enough people to get something that has some statistical validity. Do you see any problem here? With 10 binary confounders, how many distinct combinations of these confounders do you have? So how many distinct combinations of these confounders would you have? Anyone that is a little bit familiar with, but how many combos would you have? So people that are a little bit familiar with combinatorics, in this case, ways of counting, would know that we have 2 to the 10 combinations. So we have 2 to the 10 combinations, which equals 10,000 or 1,024. So, sorry, I don't know why I wrote that. So which equals 1,024. So we have 1,024 different combinations, different levels that we would, in standardization, abstract ourselves to. And we only have a sample of 300 people. So what would we do in a situation like this, where we have 10 binary confounders and a sample of only 300 people? Well, you might say, hey, we've got a positivity violation, because in each distinct segment of our population, in each subsegment of our population, we will not, of course, have, because we only have 300, both a positive and a negative example. So someone that has been treated and not treated. So we need to go gather more data, right? Okay, I want to go ahead and present one more situation. So this one, maybe we can get away with. Maybe we can go ahead and get more data. So second situation. So in this situation, I'm going to say that L is blood alcohol content. So L is blood alcohol content that has been measured from some individuals. So for example, we've got e.g., we've got some that are maybe 0.1, maybe some that are 0.08, maybe some that are 0.07, ... Lots of blood alcohol content as sampled from drunk drivers. Question. This blood alcohol content is continuous. It could be any value. In fact, there are an infinite number of values that this could be. So the number of combos of blood alcohol level, so combos of blood alcohol level, is infinite. Infinite combinations. So the only way that we're going to be able to group blood alcohol level such that we have positivity not violated is to, for each level of blood alcohol present, so maybe you'll have 0.1, 0.08, 0.07. You need to have one person at each treatment value for each level. This seems like a problem. Now, you can get away with this by doing grouping. So let's say we group everything that is above 0.08 into one bucket, and we group everything that is below into another bucket. And so that's one way to deal with it. However, I'm going to talk about a very general way to deal with this as well. It will add one more assumption, but it will become extremely powerful in the future. So the question that we have asked is, now let me go ahead and erase down here. So the question we have asked is, and the question we will solve is, how to group. How to group. Okay, let's explore this in the next video.